Okay, let's get started. This is the end of week 8. Next week we do that next section called related means. Everybody's sitting in different spots. What's going on? People are moving in different spots. Where did we leave off? Now I want to review this real quick. You ready? Here's what's going on. Now that we're in the third quarter, the third quarter of this class, it's all about 2 samples instead of just 1 sample. We started out just doing confidence intervals, then we went to 1 sample hypothesis testing, and now it's 2 samples. And next week we go to this section right here where the samples are coming from the same population, they're related to each other. And this is a big deal because this is one happens to be one that's used in business a lot, in management. This is where we're at right now, where it's 2 independent samples from 2 different populations. But there's 3 different calculations involved in that first one. If the population standard deviations are known, is the first one, which we learned last week. If the population standard deviations are unknown but assumed equal, which we learned on Tuesday. And then if the standard deviations are unknown but assumed unequal, which we touched on Tuesday, we're going to expand on right now. That's what we're talking about. And I think the hardest part of the third quiz is going to be, hey, am I using this assumed equal, or am I using this assumed unequal? And here's my hint. You ready? My hint is, if you're not being told they're assumed equal, then they have to be assumed unequal if they happen to be sample standard deviations. Don't forget, they can be population standard deviations, we know what to do, it's a Z. But if it's sample standard deviations, now you gotta decide which T it is. My hint is, if it's not telling you they're assumed equal, then you can go ahead and assume they're not equal. This formula. Now look at the 2 formulas I've added up here. Let's say that we have sample standard deviations or sample variances, and we're told they're assumed equal. The big calculation is called the pooled variance. That's part of that formula. Let me bring this formula up so you remember the pooled variance. Hang on. There it is. Here's the formula. Right there in the denominator is that pooled variance. This formula right here, I put in words. The words are the sample size from the first sample minus 1, I'm going to sneeze, it's coming up, times the variance from the first sample. You add that to the sample size from the second sample minus 1 times the variance from the second sample. That's your numerator. Your denominator is taking the sample size from the first sample minus 1, taking the sample size from the second sample minus 1, then adding them together. Once you have both the numerator and denominator, the last step is divide. Divide the denominator into the numerator. That gives you the pooled variance, which is right there, underneath the square root. Right there, that big calculation you just did is to fill in there. So once you identify this is the problem to do, step 1, pooled variance, because you can't go any farther without it. Step 2, most likely you're going to need T unless you're doing confidence interval, you need to do this test statistic. The only reason you don't need to do this is if you are doing the confidence interval. But, p-value or critical value approach, you got to do this test statistic T, and you've got to have that pooled variance. So you've got to do this formula right here. Now, let's say it doesn't say the population standard deviations are equal. It may even tell you that the population standard deviations are assumed not equal, but it may not tell you anything. Let me say this again. You're recognizing that you've got the sample standard deviations or variances, so you know it's a T. And you're trying to decide which T it is. You're then looking at it and saying to yourself, does it mention anything about the population standard deviation or the population variances being equal? It doesn't. Okay, then we're going with the last formula, which is there. This formula. This is the one we're using if we can assume that the population variances or standard deviations are not equal. Remember that from Tuesday, right there, this formula. But the tough part about this equation is getting the degrees of freedom, which is this formula. This is the tough part. Now, I want to give you a big hint. On your homework, the written part of your homework, it's having you do the same problem twice. A, as if the population standard deviations are equal, variances, whatever, are equal. B, they're not equal. You got to start off with B with this degrees of freedom formula, and I put it in words. I took that and put it in words. Ready? The variance from the first sample divided by the sample size from the first sample. There's where I start. Next, the variance from the second sample divided by the sample size from the second sample. There's that. Add those two results, square that result, stop there, put it off to the side. There's your numerator. Now the denominator is a little tougher. Take the variance from the first sample divided by the sample size from the first sample, then square it. Take that square and divide it by the sample size from the first sample minus 1. There's the left side. The right side, the variance from the second sample divided by the sample size from the second sample. Square it. Then take that and divide it by the sample size from the second sample minus 1. Take those two results, this is your last step for the denominator, add. That's the last part of the denominator is add. Then take that answer, divide it into that numerator. That's how, and then there's one more step. You've got a number now for the degrees of freedom, but there's this one last step you got to do, which is to round. What do you got to do when you round?
Down.
Very good. Down. You got to round down. You know what? We may not even round because I'm not sure we're never going to really use the table. Really, rounding it down is for using the table, and we're not going to use the table. But we're going to round down anyway, just so we know, just so we're used to it for now. But there you go. That's the first step. And then, if you're doing the critical value or approach, or you're doing the confidence interval approach, you need the degrees of freedom to find your critical value, so that you can put it into the confidence interval equation. But if you're doing the p-value approach, you still need the degrees of freedom for p-value. Go ahead.
So you round down to the degrees of freedom?
Degrees of freedom, whatever this calculates out to. Let's say it comes out to 66.72. You use 66. You round down. Even though logic tells you to round up.
And you said if it doesn't tell you anything that, if it's not,
Right.
not assumed, then it would be not assumed?
That's right. Did you hear that? She said if it doesn't tell you, you know you're looking at sample variances or sample standard deviations, and it's not telling you that the population ones are assumed equal, you have to go ahead and assume yourself that they're not equal. That you got to get this degree of freedom figured out. The good news is that this part right here, having to do this by hand, will, I'm going to say, high probability of not being on the third quiz. I may give this number to you, but you still got to recognize what's going on. What did I just give you? I just gave you the degrees of freedom, you got to realize what's going on. Yes. You have to do it on the homework.
Not on the quiz?
But maybe not, most likely not on the quiz.
We'll get that.
Most likely so, yes. Did you hear that? She said, we'll may have to do this one, and the odds are, yes, this one's not that big. This one just takes too long.
For the quiz, we're gonna have to do a question from beginning to end. So this would be a separate question?
This would be a separate question right here. Oh, no, I'm sorry. The pooled variance would not be separate because it's part of this equation. These would be together.
We'd have to do all that?
All that. If I was asking if you needed the test statistic to solve this one, and you were given the sample standard deviation, and it said, and assume the population variances are assumed equal, you gotta do this. But that's compared to this. Yeah, these are together too. This is the test statistic, yes. This is the test statistic T. Equals test statistic T. Which you would use, for the confidence interval approach or the critical value approach.
And then we would still have to, so you would only ask us for the test statistic or the whole thing with also the other equation?
Oh, once you get here, you gotta tell me whether you reject or not reject. Let's do one so you can see. You ready? Okay. hang on a minute, I got one ready, I think. Let me look here, right here. Here we go. A chartered, this should sound a little bit familiar, by the way. This was one of those questions I read, and I asked you, are we doing Z or T? So start thinking about whether we're doing Z or T. Matter of fact, I wish I could make it bigger. I don't want you to see the answer. You're looking right at it. Good looking at it. There we go. A chartered financial analyst designation is fast becoming a requirement for serious investment professionals. It is an attractive alternative to getting an MBA for students wanting a career in investments. A student of finance is curious to know if CFA designation is more lucrative option than an MBA. There it is right there. There's your hypothesis. The student wants to know if a CFA designation is more lucrative, not less lucrative, not different lucrative, more lucrative than the MBA. He collects data on 38 recent CFAs to says, hey, what's your salary, what's your salary? And the mean is 138,000 and a standard deviation of 34,000. Did you hear that sentence? It's describing the first sample. A sample of 80 MBAs results in a mean of 130,000 in salary with a standard deviation of 46,000, describing the second sample. Give the hypothesis, calculate the test statistics and p-value, do not assume the population variances are equal, use 5% significance. Can you reject the null hypothesis? Are you ready? All right, first of all, is this Z or T? T. Is it this left equations or this right equations over here?
Right.
Right.
Is it the right? Is it the right? Because of what sentence?
More.
Because of more.
No, the more is telling you it's one tail. The more, you're trying to say,
Says do not assume.
more lucrative, right?
Do not
So I
assume-
heard it down, you're saying
Do
it.
not assume that's a population variance.
Do not assume the population variances are equal. Now, don't get me wrong, in more cases than not, it will not say those words.
It didn't say that, but it would still be not assumed.
But it's still being not assumed, because if it's not telling you they are equal, you have to assume it's not assumed. Once you recognize that it's the sample standard deviations. So this is the formula right here, the go-to formula basically. It's this one over here. So let's do that formula. First we're gonna write the hypothesis. The first mean is gonna be the CFA designations, which is 138,000. The second sample, mean number 2, will be the 130,000. We're testing whether one is more, the average is more than the other. So the one tail, what we're trying to prove is gonna be in the alternative hypothesis. So it'd be, if the first one is 10 and the second one's 8, when you subtract them, you're gonna get above a 0. So greater than 0 would be the alternative hypothesis. So let me scroll down. There it is. One mean minus the second mean is greater than 0. So the alternative would be, or the null hypothesis would be the exact opposite, less than equal. One minus the other, less than equal. So there's our hypothesis. Now, we just recognized this problem. So once we recognize it's this problem, we got to get this degrees of freedom. But unless we're doing the p-value approach, do we need degrees of freedom? Well, let's look at our handy sheet here. Degrees of freedom with a T, sure do. To get your p-value, underneath p-value, that what I had you all take a picture of before the second quiz, it says the first number is your test statistic T. The second number is your degrees of freedom. The third number is either a 1 or a 2, depending on how many tail tests this is. So I'm gonna put this on the board. This is what we're eventually gonna do right here. Number, number, number. What's this last number? We can fill this one in. 1. Very good, the one tail. There's that. So now, we gotta get our first two numbers. So let's get our test statistic or our degrees of freedom. What do you wanna do first? Degrees of freedom's on their side. It's already there. There it is. Look at the formula now. Here's the words. Variance 1. It didn't give us the variance. It gave us the standard deviation for the sample, 34,000. So we have to square it to turn it into a variance. Divided by sample size 1, 38. Plus the variance number 2. It gave us the standard deviation, not the variance, 46,000. We got to square it to turn it into the variance. Divided by 80 was the sample size. Add those together, square it, there's our numerator. Denominator, again, that variance number 1, we gotta take the standard deviation and square it, divided by the sample size, 38, square that number, then whatever you get, divide by 38 minus 1, which is 37. Over here to the right, take that standard deviation and square it to get the variance. Divide by the sample size 80, get that number, square it, then divide by 80 minus 1, which is 79. Now take the left-hand result, the right-hand result, add them. Then divide them into that numerator, 95.5. Round down, leaving 95. All of that just to get the degrees of freedom. Now we can go ahead and fill this middle number here, 95, to get that p-value. All we need now is the test statistic. But we already recognize this is not assumed equal, so here's our test statistic formula. The first mean of the sample, the second sample mean subtracted, divided by those variances, divided by the sample size. Now don't forget, on the quiz 3, most of the points are in the setup. You identify the right equation and set it up, you're on your way. I mean, that's gonna be the hardest part, and that's just doing some math. Personally, if there's a time constraint, I'd start setting them all up and then do the math with the rest of the time that's left. So I'm sure I took this and took the, there it is, 138,000, was that 138? 138,000 minus 130,000, there's sample 1 minus sample 2. There's the 34,000 squared to get the variance, divided by the sample size 38. There's the 46,000 squared to get the variance, divided by 80. Add those up, square root the whole denominator and plug it in. There's our test statistic, 1.061. 1.061. What if that would have been negative 1.061? What would I have to do here? Do I have to add a 1 minus in front? No, you just drop the negative. Very good. Very good. Use no, stop. What is it again? 1.061. Somebody plug that into Excel and get ready to tell me what that answer is, because that's our p-value. Where do I have a minus? Oh yeah. Don't forget, ignore that. I took that out of the equation because it will always be 0. And if it's 0, it has no effect on this equation at all. And I took it out of this equation too. This would have minus 0 here. I took it out of there, minus 0 here. I took it out of there, and the first equation with z. So you can ignore it. Don't be wrong, there are going to be in the future, not in this class, but you know, if you go into advanced statistics like for your master's, there are problems where the null hypothesis and alternative hypothesis are not equal to 0 when you have two different samples. So we're focusing on where we're trying to figure out there's a difference between them. Either one's more, one's less than, or just different from each other. And in that case, it's always 0. I'm hoping you'll go at least 3 digits to the right of the decimal, but 4 would be great also. And sometimes I'll go 5 just to make sure I know what the next digit is. So we plug this in, 1.061 comma 95 comma 1. We get a p-value of 1.1457. Is that what you said?
Yes.
Oh, very good. Now, we compare that to our significance 5%. Since this is greater than 5%, we do not reject the null hypothesis. We got to put it in words. Quiz 3, there's another quarter of a point to give me the words of what that means. Relate what we just did. We cannot reject the null hypothesis. The person who's trying to examine something is not going to be able to prove that that is true, whatever it is they're trying to examine. One was not much more than the other. So here's an example of how I put that in words. And we were comparing the CFA designation to the MBA designation. And the researcher said, the reason we put the alternative, that the CFA makes more than the MBA, because that's what the researcher was trying to prove, or the student was trying to prove. And so we have to now say that has not been proven. So here's one way of putting it. Ready? We cannot conclude that the CFA designation is more lucrative than the MBA designation at a 5% significance level. You're just taking the words right out of the problem and stating it, but add to it at which significance level you did this examination. And we cannot say that one's more lucrative than the other at 5%. So don't forget, we're taking it a step farther on quiz 3. We're not just giving now the hypothesis, showing all our work, then doing a comparison to then either reject or not reject, but then we're also giving a sentence to give the conclusion as to what it means to reject or not reject in words. This is full circle, we're almost there. You realize we're way past halfway done with this class now, right? This is the end of the eighth week. All right, so now, look at this. Critical value approach. Same problem, critical value approach. Went ahead and used the critical value formula for T equals TINV, parentheses. Why did I use 10% instead of 5%? 0.10 instead of 0.05. Why? For the first number in the TINV.
Because it's one tail.
Because it's one tail, you had to double your significance. So double the 10%, degrees of freedom 95, that big equation we did. 1.661 is our critical value. What was our test number? 1.061. Is 1.061 inside closer to 0 or outside of 1.661? Inside, closer to 0. Therefore, we cannot reject. We cannot reject because it's inside, closer to 0 than our critical value is. We cannot conclude that the CFA designation is more lucrative than the MBA at the 5% significance. Same conclusion in words, but this time we use critical values. We're getting out early. Ready? Come on, you guys. We got just a little bit, 2 more problems. Confidence interval approach. Notice I'm taking the sample means 138 minus 130 plus or minus that critical value we just calculated, 1.661, multiplied by the square root. We're right here. Where are we? Oh, I don't have the critical value formula there. Divided by the square root, but we do have this right here. The square root of the sample standard deviation 34,000 squared divided by the sample size 38 plus standard deviation of sample 2, 46,000 squared divided by the sample size 80. Do all the math on that. Look at our upper and lower interval. 20,526 and some change. The lower one, negative 4,526 and some change. Now you're looking to see if the hypothesized number fits in that confidence interval, which is 0. Since one of those numbers are negative, the other one's positive, 0 fits between them. Since 0 fits between them, we cannot reject the null hypothesis. We do not have evidence that the CFA designation is a more lucrative option than the MBA at 5% significance. Same conclusion using all 3 approaches with a not assumed equal problem.
Are we always comparing it to 0?
I'm sorry?
Are we always comparing it to 0?
The confidence interval, we are always comparing it to 0 in this class. Because we're always going to have for our 2 mean, at least at this point, unless we want to do one that has a different number than 0. I don't know if we want to. All right, let's take a look at this. This is from page 352. Let me open up 352. I need you to start getting used to seeing this. Look at this. We're now got to start looking at these computer outputs and what do they mean and how do you read them. Excel, this is an Excel output from raw data. Gotta bring the volume down, you guys, just a little bit. Go to a whisper, please. So look, we got 16 is gold's mean, oil is 17.3. There's our means, there's our variances of these 2 samples. These are 2 samples. There's our observations, there was 10 in each of them. Our hypothesized mean difference. This, whatever the hypothesis, whether it's 1 tail or 2 tails, equal to 0 in some way. There's our degrees of freedom on this output. What else we have? Our t-stat. So however this was calculated, there's the result, negative 0.3023. There's our p-value if this happens to be a 1 tail. There's our critical value if it happens to be a 1 tail. Our critical value, 1.7396 if it's a 1 tail. If this happens to be a 2 tail, it gives us the results, whether it's 1 or 2 tail. If it's a 2 tail, our p-value is 0.7661. Our critical value, 2.1098. My question for you is, what numbers are you looking at on this output to answer the question, using the critical value, and this is 1 tail, would you reject the null hypothesis? What numbers are you looking at? And would you reject the null hypothesis using critical value approach, one tail? What numbers are you looking at? Not all at once, because we are recording. And I'm sure you can't pick it all up.
The T-stat.
The T-stat, which T-stat? Right here, there's only one T-stat.
Yeah.
Negative 0.3023 she's looking at, and she's comparing it to what?
The T critical one tail.
The T critical value,
One tail.
one tail. Right there where my thumb is, these two numbers. Is negative 0.3023 inside, closer to 0, or outside 1.7396. Now remember, this 1.7936 could be positive, could be negative, it could be either one.
Inside.
So my question is that inside or outside?
Inside.
Which means you can or cannot reject?
Cannot reject.
Cannot reject because it's inside, it's inside. Switch it to two-tail for a minute. Does the result change? Are you still rejecting, yes or no?
Yes.
Now we're comparing this T statistic to the two-tail critical. It's way inside, closer to 0, more than the one tail, so we definitely cannot reject, correct? You're still with me on this one. All right, let's talk about p-value. If this is a two-tail p-value, what are you comparing it to? What number are you comparing to what? What is the significance? Oh, does it say? Did I say? Did I not say? Oh, okay, 95% confidence, so what's significance?
5%.
5%. So what do we, and then I said two-tail or one-tail p-value?
Two tails.
Two-tail, so what number are we looking at?
0.7661.
Right there, we're comparing that to 5%. Is this more than or less than 5%?
More than.
Can we reject or not reject?
Not.
Not reject, because it's more than, can't reject. Switch to one-tail p-value, still comparing to 5%, correct? Still comparing to 5%, but what number are we using? 0.3830, is this more or less than 5%?
More than.
More, oh stop, more than, that's 38%, that's gotta be more than 5%. More than, which means we can or cannot reject? Cannot reject, you're getting it. You can read these, right? You can read them, we got that?
Is
Okay.
observation sample size?
And what about, oh yeah, well, degrees of freedom and sample size, what were you gonna say? We don't, first of all,
Wait, sample size? Just kidding.
the sample size on there's, where is it? 10 for gold and 10 for oil, so they both have 10 for their sample size. I wanted to see if there's anything in here that says that their population variances are equal or not equal. Uh-oh, what did I just do? Let's see, the value of test statistic is it can be two-tail, one-tail, just give you this. 5% significant level, we cannot reject, yeah, we saw that. Return industry doesn't say anything about the populations in this example. Let's go down here farther in the answer and see what is. Okay, let's look at this answer. You tell me, by looking at this answer, I gotta look at it carefully, there we go. By looking at this answer, just looking at it right now, looking at what formula is being used, can you assume, even though we can't find it in this problem, can you assume the population variances are equal, or the population variances are not equal? Look at it, look at the formula being used. This has to be confidence interval, but there's something about the formula that identifies whether it is, the population variances are equal or assumed not equal.
Assume not equal. Critical T.
Equal, and what'd you say?
I said not equal.
Not equal, and she's saying equal because of this critical, but this critical, that critical, I don't think that's what's giving it away. You're saying not equal though because of why?
Because of the formula, the bottom part.
She's saying that this denominator right here, variance 1 over sample size 1, variance 2 over sample size 2, is the same formula here, which is variance 1 over sample size 1, variance 2 over sample size 2, which makes this not assumed equal. Not assumed equal is going on here. Which means this degree of freedom was calculated this way. And if we go look at this sheet, I want to show you where these numbers came from. Let's go back to that readout real quick. I want to show you where now that we know what kind of problem it is, oh, I can't believe I just did that. Darn. Don't grab the thing and pull on it. Again, here it is. Okay, now, don't forget, right here. So to figure out that test statistic, I took the first sample mean 16 minus the second sample mean, square root, there's the variance over 10, the variance over 10, and so on, and I got negative 0.303. Go back to that output. Where is it? That's that number right there, negative 0.303. That's how it was calculated, using this calculation right here at the bottom here, to find that test statistic. Now this is all posted, by the way, this whole printout's posted. To find the critical T, it's equals TIMV, 5% if it's two-tail, 17 degrees of freedom. If I did the whole degree of freedom formula, I would have got 17, but actually I got that off of that printout. And I get 2.1098, positive or negative. Now let's look at the two-tail on the printout. There it is, two-tail, 2.1098, right there. And then on here, if I did p-value, I did equals t-distribution, 0.3023. Notice I dropped the negative off right there. 17 is the degrees of freedom. 2 for two-tail, got 0.7661. Go look at the output. There's where that 0.7661 came from, right there, that formula. So you can match all of this up to all the formulas we've been learning to that computer printout. The confidence interval comes out to negative 1.3, and the upper is 9.07. My question is, can you reject or not reject based on that confidence interval? You know the answer is right there next to the words. Reject or not reject if it's between negative 1.3 and positive 9.07. Reject or not reject? Not reject because why? Because 0 is between those two numbers. If 0 is between the two numbers, you can't reject. Notice one of the numbers is negative. By the way, you go to the printout, there's your upper, hang on, right down here. Here's the calculation for the upper and lower confidence interval, negative 1.3 and 903. And it says right here that at 95% confidence interval, or 5% significance, the difference between the two means ranges from 10 point whatever to 7.7, I don't know where that's coming from. We note that the interval contains 0, so the value hypothesized under the null hypothesis using 95% confidence interval, we cannot reject or support the conclusion that the population mean returns are different than 5% significance. That's talking about 2-2. Anyway, all right, now how do you do it? Here's where we're at. These are posted. Here's how to do it. I'm going to try to make this bigger so you can see it. This is some hypothetical data here. A lot of you are going to go to your insert tab right here. Hang on, let me find it. Right there on Excel. You look to the far right. What happened? It's gone. Or data tab, I'm sorry, data tab. Go to your data tab, go to the far right, and you'll see if data analysis there. And most of you won't have it because you never installed it. So whichever one of these problems, these examples you open up first, it gives you instructions how to install to get that data analysis. I'm going to show you real quick. It says, if you do not have data analysis options, look under the data tab. Let me scroll over. Install it by selecting file right there. Then select, I believe it's options, even though we can't see it now. I don't have it memorized, hang on. Select file, then select options, it is options. Then select add-ins, then select analysis tool pack. Then look downward at the bottom where it states manage add-ons, select go, then select data analysis tool pack. So I'm going to do that whole thing. Follow those when you're at home to install this. You need it for the quiz, most likely, unless you get an output. But file, I'm looking for, I thought maybe I'd go to get add-ons, but I'm doing it the old-fashioned way. I'm going to where it says options, right there where it says options. Now you want to go to where it says add-ins, right there, left click on add-ins. Now you want to make sure and left click on analysis tool pack. Go down here where it says manage Excel add-ins and has the word go. Now you select analysis tool pack. Make sure the check mark's right there. When I click OK, it will install it, but I already have it installed. I just wanted to get you to that point to install it. Did everybody see that? I did it kind of fast, but the instructions are right there, step by step. Now, I have it installed already, so I'm going to the second set of instructions where it says, select the data tab and select the data analysis, then scroll down and select the two sample assumed equal. Okay, follow those directions, here we go. Select the data tab, right there. Now go to the data analysis, right there. Now select, look at all these options here. We're doing t-test to sample assuming equal. The other Excel spreadsheet, you're gonna select this one below it, assumed unequal. But right now we're doing assumed equal variances, right there. It will open up a dialog box. Now, I wanna make sure everybody hears this. This is where everyone blows it. We're using labels. Look at me, I'm gonna check this box right here called labels. By doing so, you want to include the label up here in your ranges of data. So I'm going to do variable 1 range, but notice I'm starting where the word gold is. Include the label. So I left click there, I'm holding down my left click, I'm scrolling down to the bottom of the data. There it is, from C7 to C17. Now I'm going to where's the data for number 2? Again, include the label. Because I'm clicking the label box and I want you to have labels. Left click on the label, scroll down, include all the data. There it is. Next, output range. On the homework, it's asking you to put the output right there on the spreadsheet. There's two problems on the homework on the Excel spreadsheet. It's asking you to put the data there. I don't care if you put the data there or if you use a different worksheet. But when you go to answer the questions, you've got to look at the results that you're about to get. So it's easier if you put it right on front, but I'm going to use a different worksheet. New worksheet just because it's easier, it's just fast. So here it is. I got it all. Oh, I forgot. Hypothesized mean. This is where you put 0. There's the 0. There's my ranges for each set of data with the labels. I click the label box. My significance 5%. Is my significance, is this a 5% problem? I can't remember. Now let's assume it is, because this problem's hypothetical anyway. 5%, new worksheet. You ready for the data? My question for you is, let me widen it up so you can read it better. Okay, here it is. My question for you is, let me stare at it for a second. Hang on. Oh, hang on, I gotta make it even a little wider so you can see all the words. There we go. If this were a one-tail, use the critical value approach, what numbers would you look at to determine if this can be rejected or not rejected? Let me repeat my answer. I'm going to stand right here and use the pointer. Critical value approach, one tail, can you reject? What numbers do you look at? What's the first number you're looking at? T-stat, negative 0.30233. This looks familiar, by the way. Then what are you comparing it to? Critical T, one tail. Did I say one tail? I said one tail? Yeah. 1.734. Now, without me saying anything, can you reject or not reject? I heard it over here. Is that Daniel? Okay. Not reject because negative 3.0233 is inside closer to 0 than 1.74. Whether that's positive or negative 1.74, our test statistic is inside it, closer to 0. So we can't reject. All right? Now, if I want you to prepare for quiz 3. You're given this output, and the question is going to say, give me what numbers you're using, and explain, can you reject or not reject using p-value for a two-tail for this problem with 5% significance? Can you reject or not reject? What numbers are you using?
The two-tail would be the 0.76.
Look at him. She's all over it. All over it. That's right. Two-tail p-value. 0.765869. What are you comparing it to here? Help her out. Significance, which is 5%. Is this greater or larger than 5%?
Larger.
Greater is larger, it is.
Larger.
So you reject or not reject? Not reject. You can't reject, and that's what your answer is going to be. The p-value for two-tail is 0.765869. This is larger or greater than the significance of 0.05. Therefore, we cannot reject. Now I want to do another one. This time, we'll go into this other example. This will be as if we're assuming the population variances are unequal. They're not equal this time. Nothing changes. We're going to use the same data analysis. So I'm going data analysis. But this time I'm scrolling down to where it says unequal variances, right there. All right, hit OK. There's our dialog box. I'm doing the same thing. Hit labels. I'm leaving this at 5%. I'm putting a 0 in there. Gonna do a new worksheet. Where is the first sample? Don't forget to include the label.
Wait, what's the alpha?
Significance. Alpha is the significance. Okay, then the second sample, the data, include the label. There it is, highlighted, including the word oil. Just that easy. This time it's unequal. I'm gonna hit OK. I'm gonna ask the question. Let me make this wider. Oh, come on. Look at, if we could have these two right next to each other, you'd only see slight differences in the numbers. Notice the t statistic is like really close to being the exact same number. Negative 0.30233. Let's call it a one-tail critical value, 1.7396. Same answer, you cannot reject. My question is, if on the homework, can you make an output like I just showed you for both assumed population assumed equal variances and assumed non-equal variances? Can you do this output? Because that's the other part of your homework. Don't forget, use the worksheet posted for the homework. Hand back in that worksheet with your saved answer on that one. That's the one you're submitting with the picture of your answers for the written part also, those two problems. And that's your homework. Yeah, you're handing them both in together. You have those A and B on the written part, and then you have the Excel part A and B, and then you got to answer 2 questions. Type in the answers to those 2 questions. Let's look at the Excel. I can see some blank looks. It tells me I better look at it. Hang on. Let's look at it. Here it is. Boy, you think this computer, there we go. It says, use the data analysis tool, t-test 2 sample assuming equal variances. I'm literally telling you which tool to use to determine the 2-tailed test statistic and the p-value for the data below. Use 5% significance. Include the data table results when you submit your spreadsheet. Now you can put them, you can see that I've already done it before on the right here, but I got rid of the table. But you can put it there, you can put it here, you can put it over to the left, put the table on another sheet if you want. But there's the first one, and then you gotta answer this question. Explain in 1 sentence if you can or cannot reject the null hypothesis using the 2-tailed p-value and 5% significance, and why. So there's that one. Now, the next problem. This one. Use the data analysis tool, t-test 2 sample, assuming unequal variances. You're using the same data. You're just doing a different problem. You're putting that data, that table, either down here to the right, over here to the left, on a separate sheet. But then you answer this question. In your answer should be the numbers off the table, showing me you're reading the numbers from the table. Explain, whoops, hang on, where is it? Explain in 1 sentence if you can or cannot reject the null hypothesis using not the p-value this time. This time you're using 2-tailed critical value approach. And why? You're telling me which number you're using, which you're comparing, whether you can reject or not reject. Everybody get how to do this assignment now? When you mean 5? Oh, sheet you mean? Like when you create that table, it can be on a different sheet. It'll be another page.
Oh, on the same file.
Yeah, look how I'll make one on this sample. Look how I did on this sample right here. Where is it? Right here. See how it made a separate sheet right here, and then here's the original data. Whoops. Here's the original data right there. But when I said make your table, it showed up on this next page down here. Here it is from last semester, or I'm sorry, 3 years ago.
Oh, we did the questions on there too? 'Cause I want to submit.
No, yeah, you're answering the questions right in the same spreadsheet. All on one spreadsheet. This whole thing is done right here on one spreadsheet, but you might have a separate sheet. Like here's a second sheet with your tables on it if you want. Yeah, but you don't have to. You can put it all on one sheet. But type your answers out on here, and then you're submitting this Excel spreadsheet. Save it. And look, here's how you change the name. Just go File, Save As, Browse, and then it comes up with the name that's on there now. Just change the name. Just add your name in there somewhere, and then just hit Save. So now you have it with your name on it. So it makes it easier for us to keep it organized there when we're grading it.
And we email it to you?
Yeah, just email it to me, with your answer for the written part too, all in one email. This is due Tuesday like normal, it's just, you're handing a spreadsheet for, I think we only had one other spreadsheet before this. But on the written part, you're still writing out your Excel equations just like you need. Okay, I got one more thing to show you, which is, I wanna go to PowerPoint, slide 19 here. Okay, I'm refreshing your memory. I think this is Z, no, is this T? Oh no, we're doing T. We have all the numbers up there to do confidence interval. Remember, this one is, I gotta remember which one is this. This one is assumed equal. This was the problem, I wanna refresh your memory. Here's what the problem was. We were looking at the New York Stock Exchange versus the NASDAQ, and right here it says, where's my pointer? Right there it says, assuming both populations are approximately normal with equal variances. That's why we're using the first formula here. Now what you don't see here is you don't see the equation for confidence interval. But confidence interval is just taking the sample mean of 1 minus the sample mean of 2, add and subtract the critical value times this denominator part. So I'll put it right over here. But help me out with the numbers. Matter of fact, I'm gonna take all of the numbers that you need are right there. Well, not there. There's all the numbers you need. Here we go. The first sample mean is right there, 3.27. Minus the second sample mean, 2.53. There's that. Plus and minus, we're doing the confidence interval here, plus and minus, the critical value is right there, 2.0154. 2.0154 times. Now, what are we multiplying it by? It's the same thing we use in the denominator when you're finding the test statistic. So we're gonna use the square root of all those numbers, 1.5, let's see, square root of, I just put a line here with a square root symbol, 1.5021 times 1 over 21 plus 1 over 25. There's our confidence interval formula right there. We find the upper and lower interval, and then we look to see if 0 fits between them or not. I think I did I do this already? I did do all, no I didn't, I only set it up. So I didn't, oh wait, is the answer in here? No, it's not.
For the quiz, the conference interval only has samples for 1 tail.
Yeah, we can go ahead and do confidence intervals with 1 tail. We're still doing the same thing, you're just deciding if 0 fits or not, even if it's 1 tail. All right, you ready for the in-class assignment? You got 15 minutes.